So this is day 2 of SAT Math Crash Course. We're going to jump right into the questions. I'm going to start with all the homework problems. In fact, you see the first homework problem here was question number 11. So we're gonna go with that. And I do want you to try these questions on your own, which is why I'm having you do the homework. We'll go over them all, so don't worry if you weren't able to solve them entirely on your own. But like I said, I do want you to try practicing these on your own. I think it's important to practice these skills. Okay, so question number 11. I would love. I'm going to volunteer someone. Christy, can you start us off reading question number 11? I'm going to share my screen as well.
Which of the following numbers is not a solution of the inequality?
Yeah, that whole thing. All right. And I'm bringing up my screen. Can you guys see my screen yet? Can you guys see my screen?
Yes.
Okay, you see it?
Yeah.
Okay, good. All right, so there's an algebraic way to do this. You guys have seen inequalities before? Some of you? Yes or no?
Yes.
Some of you. Some of you maybe not. And I think this always intimidates students because, like, if there's an equal sign there, like, everybody knows how to do it. Well, many students know how to do it. But when you see, like, that greater than or less than, it's like everybody flips out. And algebraically, the rule is you treat it the exact same way that you treat an equation. The only difference is if you multiply or divide by negative, then you have to reverse the sign. That's the only difference, okay? But that still throws everybody off. So let's just solve this one by plugging in values in place of the variables, okay? So, Christy, I'm gonna start off with you. Can I see you plug in? The answer choices in place of the x variable here on the whiteboard? Very good. We're looking good, right? So we're just plugging in answer choice A. This is great, Christy. Okay, if you need help, I will totally guide you through this, but this is looking good. We're just plugging in the answer choices here. Now remember, the question says, which of the following is not a solution to the inequality? So if we find out that -1 doesn't work, that's the correct answer, all right? Can you simplify that left-hand side of the equation?
Yes.
Great. So it's 3 times -1 is, yeah. So 3 times -1, oh, there we go, okay. So that's going to be -3, right? 3 times -1?
Yeah.
Is going to be -3. And let me help you out here with that one. I'll erase that. Good. And then -3 minus 5. Do you know what to do with those, Christy, when you see two negatives here like that? -3 minus 5 is, yes, very good. -8. Excellent. All right. And then the right-hand side of the equation, it's going to be similar. That 4 times -1. It's going to be negative. Exactly. Yes. Okay, now let's stop here real quick. Okay? So again, which of the following is not a solution? All right. Is -8 greater than or equal to -7? Is it?
No.
No. It's less than, right? Because the bigger the absolute value of a negative number, right? I mean, like -1 billion is really negative. That's a lot less than -7, right? Even though it's a bigger number as far as absolute value goes, right? The size of the number without the negative sign. Because it's more negative, it's less than. Does that make sense, guys?
Yes.
Okay, so that's kind of the concept they're testing on here. So the correct answer, because A is not a solution, A is the correct answer. Does that make sense? Yes or no?
Yes.
Okay. And whenever I see anything, guys, and this is kind of a helpful hint as well, on the SAT, whenever I see something in all caps, oops, I'm on the erase function here, like the not right here, or if I see something underlined, I always circle it or make some note of that, because I see a lot of kids, even kids that totally understand this concept, they'll plug in that -1 for x, and they see it's not a solution, so that's not the right answer, right? Because we're thinking generally in terms of what solves an equation or an inequality. And then they plug in -2, which works. It gives you a true statement, but they're not asking for you which one gives you a true statement. They're asking which one is not a solution. Does that make sense?
Yes.
Okay, so this is also a good example of just reading the question carefully and understand what's being asked. Okay? Are there any questions about number 11? Okay, so we're good? Let's rock and roll. And the next question, I'm going to clear the whiteboard again. From the homework is question number 16. And I'm going to zoom in just a little bit. This one doesn't look like it initially would be like a plugging in values for variables question. It looks like a graphing question, which it is. All right. But we can use this strategy again on lots of different kinds of problems, including this one. So let's. I'm going to start. Irene, can you hear me?
Yes.
Can you read this question for me, please? Question number 16. And then you start with like the left-hand side. It says the graph above.
Yeah, I'm trying to read it.
Do you see where it says the graph above displays? On sort of the left-hand side of the problem. I'll read it for you. I'll get started on it. All right, so it says the graph above displays the total cost C in dollars of renting a boat for H hours. And then we see the graph here on the left-hand side. It's a linear function, linear equation. And then question number 16 says, which of the following represents the relationship between H and C? Okay, which is sort of a fancy way of saying, what's the equation for this line? Right? Because instead of, normally we see like the X and Y variables when we're dealing with lines here. This is the exact same concept, except instead of X and Y, the X value is H and the Y value is basically C. Does that make sense, guys, or no? That makes sense? It's essentially like the C right here. This is the C axis. That's just like the Y axis, roughly. And the H axis here, that's essentially just like the X axis, right? And that you're more familiar with when you're graphing on an XY plane. All right, so basically, again, it's a fancy way of saying which of the following represents the relationship between H and C. What's the equation for this line? Okay, some of you are familiar with Y equals mx plus b mode, where the m value is the slope, the b value is the y-intercept. I've got a section on that on the rules for mathing, on graphing. But don't worry about that right now. Let's just plug in values in place of the variables to see which gives us the correct answer choice, okay? So here's what we're going to do. We're going to take some of these ordered pairs, right, on this graph. It's like that guy right there. That's an ordered pair, 0, 5, right? Because essentially, let's speak of this in terms of the xy axis. The x value is 0 and the y value is 5. So it's 0, 5. Okay? Are there any questions about that, or does that make some sense? Any questions about that, guys? Why that's a 0, 5?
No.
Okay. We can essentially, that's that h value, or the x value is essentially 0, the y value is essentially 5. We could also call the h value is 0 and the c value is 5, okay? Or this guy right here, this is another ordered pair. That would be 1, 8. Okay, because the x value is 1 and the y value is 8, or you could say the h value is 1 and the c value is 8. Same kind of concept. Okay, so if we take any one of these ordered pairs, the correct answer should give us a true statement when we plug in the h value for, 1 for the h value and 8 for the c value, okay? So right here, let's take this ordered pair here, this 1, 8. I'm going to plug that into the answer choices right here. So let's plug that into answer choice A. And I would love to see, Claire, can you hear me? I think your mic is off. Oh, can you hear me? Maybe not. Hannah, can you hear me? Hello? Okay, gotcha. You're good. Don't worry about it. Your mic is being weird. Laura, can you hear me?
Yes.
Great. Can you plug in those H and C values in for A? And if you got questions about it, I'll guide you through it. Don't worry. Don't worry at all. So basically, we're plugging in 8 for C and 1 for H. Okay. Great. So 8 equals 5. Do you guys understand what this is? Yep. That 8 is coming from the C value right here. And that 1 is coming from the H value right here. We're just plugging it into that equation. Is that a true statement, Laura? Laura, is that a true statement?
No.
No, that's crazy, right? 8 does not equal 5. So we don't have to worry about A as an answer choice. A is gone. What about B? Can I see you plug in those C and H values for answer choice B? Very good. Looking great, Laura. Looking great. Now, hold on, Laura. I'm going to stop you real quick. Do we even need to calculate that, or no?
No.
No. I mean, like we could, but it's just like it's going to be less than 6, and certainly not going to be 8. So don't even worry about doing the addition there with fractions. Just this is where again we can apply the basic logic to eliminate incorrect answer choices. You don't always have to carry out a complex calculation. So B is gone. Let's try C. We're doing the same thing. Is this making sense, guys?
Yes.
To one person, apparently. I'll take it. Looking great. All right, does that give us a true statement? Laura? Laura, is that a true statement?
Yes.
Yeah, it is, right? I mean, 8 equals, 3 plus 5, which is 8. So that's good. We can't eliminate it. Let's try plugging into answer choice D. Yeah, and that's the craziest of them all, right? So we can eliminate D. It is answer choice C. Okay. Now, this, I would say, probably about 90% of my students get this question wrong the first time, especially if they're thinking in terms of graphing. Because what's the slope of this line? What's the slope of this line, guys?
It's 3/4.
Everybody thinks it's 3/4. You're in that 95 percentile of students. Everybody thinks it's 3/4 if you're counting the boxes, right? Because it's like you're going up. We'll start from this point and go to this point right here. Okay, do you see that? Maybe you don't see that in green. Let me give you another color here. Yellow. All right, starting from this point and going to this point. I'm going to zoom in a little bit so you can see a little bit better. All right, so starting from that point and then going to this point, we go up 3, 1, 2, 3, and over 1, 2, 3, 4 boxes. Yeah, you go up 3 over 4 boxes. That would be 3 over 4 if we were just counting boxes. But we're not counting boxes. We're counting units. How many units do we go up? It is 3 units. It is 3. That stays the same. How many units do we go over? It's not 4. How many units do we go over, guys? 1 unit. 1 unit. Right? So the slope is actually 3 over 1 or 3. Everybody gets it wrong. Unless you plug in values in place of the variables, and you'll catch this. Does that make sense?
Yeah.
Okay. Now, I'm not saying you can't use like y equals mx plus b form. You can do that. Let me bring up the rules for mathing here. Can you guys see my screen here? I've got the rules for mathing up on the screen.
Yeah.
Everybody can see that? Okay. All right. We've got the big 4 rules, of course. But then, the basic concept cheat sheet, I've got a section on graphing that addresses this issue right here. Always pay attention to the units on the XY axis. just as a heads up, they're rarely trying to trick you on the SAT. Very rarely. But one way that they are always trying to trick you is messing with the units on the XY axis. They're not always intuitive. 1 square doesn't always equal 1 unit. In fact, often it does not. So be on the lookout for that. Does that make sense?
Yeah.
Okay, but you can sidestep that completely. You don't even have to know exactly what the equation is, as if you plug in values in place of the variables and see what gives you a true statement. Okay? All right, that is a tricky one, unless you plug in values. All right, so let's go to the next guy here. I'll clear whiteboard. Did anybody get that, by the way? Did anybody get the correct answer choice for 16?
Yeah. Yes, but not with that.
You just use y equals mx plus b form, which is cool too, but you see the other way as well, how to do it?
Wait, I have a question.
Yeah, absolutely. Thank you so much. By the way, I appreciate it. Yeah, anytime you guys have questions, don't be shy. That's how I know what you don't know, so I really appreciate it. Who's speaking, by the way?
Claire.
Claire, yeah, what's up, Claire?
Hi.
Hi. You want me to bring that question back up?
Huh?
Do you want me to bring that question back up? Number 16? What's your question? Claire?
Wait, can y'all hear me?
You're kind of in and out. I can hear you at the moment. Can you hear me?
Yes, I can.
Okay, good. So what's your question?
So, I mean, I understand the form you use to do this, and I understand the form that you explained was harder to do this. But me, I just kind of like DIY'd it, and I got the correct answer, and it seems just more intuitive to me.
Yeah. To just use like y equals mx plus b.
I have no idea what that means.
Oh, yeah. Sorry, I apologize.
I just looked up there and saw that the first.
Go ahead. Oh boy,
and that's clearly 3 plus 5, and then it kept increasing by 3. So that seemed to me that C was the correct answer.
I love it. Yeah, if you can sort of logic it out like that, then that's great. That's perfect. I want I'm just giving you some tools in your toolkit, Claire. Like I'm not saying like you must do it this way, or I mean, dear, good heavens, far from it. Like I just want to give you as many tools as possible, because you're going to see some questions on the SAT that you don't know how to solve for using like the specific operation they're kind of testing you on. So this is just a tool. If there's an easier way for you to do it, I strongly encourage. I want you to do it the easiest way. Absolutely. Does that make sense, Claire?
Gotcha. Yeah.
Yeah. So please do. In fact, I mean, you see, for as far as the rules for writing go, and I'll go back to the rules, the rules for mathing. I've got rules for writing as well in the writing section. So I apologize if I referred to them as the rules for writing. So for the rules for mathing, the second rule is eliminate answer using basic logic. So you were doing that, right? Even if you weren't plugging in values in place of the variables. So I applaud that. I think that's great. Do what's easy for you. And if, like I said, if y equals mx plus b form is easier, and I'll all right, let Matthew in. Hey, Matthew. Can you hear me, Matthew? All right, welcome, Matthew. If you can hear me. So when I say y equals mx plus b form, that is the it's like this: y equals mx plus b. That's where the m value is the slope or the rise over run, and then the b value is the y-intercept. And in this case, it'd be the c-intercept. So the y-intercept is 5 right here. That's 0, 5. So it's y equals mx plus 5. And then the m value, remember, is the slope, and we said the slope is rise over run, so it's up 3 over 1. So y equals 3x plus 5. But again, that would be the c and h values instead of the x and the y values. If that didn't make any sense to you, don't worry about it, because the first way works just fine. But I want to clarify for you, Claire, because you said you're not familiar with y equals mx plus b form for graphing lines.
Thank you.
Okay, no problem. Thank you, and thank you so much for asking questions. I really, really, really appreciate it.
Thanks.
Yeah. Otherwise, just like, don't show up to class, just watch the video. I mean, and then you can sleep in. Hey, I didn't give you that idea. I was not trying to encourage you to Skip class and sleep in. But anyway, but yeah, ask questions. That was the takeaway there for that one. All right, I'm going to clear this. And let's go to the next. On to homework, which was number 31. Ooh, this is interesting. Now, on 31, interestingly, there's no variables here. So I kind of threw this at you, and I wanted to see if you'd kind of be able to figure it out and think in logical terms for this one. But even though you don't see any variables here, we can use the exact same strategy we've been using this whole time. So, Maria, can you hear me?
Yes.
Can you read question number 31 for me, please? It's on the whiteboard. Can you hear me, Maria?
Yes.
Yeah. Can you read that for me, please, out loud, preferably?
What?
Yeah. Go ahead. I'm sorry. I think her mic is cutting out. So I will have Matthew. Can you hear me? Matthew. Yes. No. Mudblood.
Yep.
Can you hear me? Great. That's Ryan, right?
Yeah.
I'm amazed I remember that. I have no idea. I'm so terrible with names. But all right, Ryan, can you read question number 31 for me, loud and proud, please?
Yeah, sure.
Great.
Wyatt can husk at least 12 dozen ears of corn per hour and at most 18 dozen ears of corn per hour. Based on this information, what is a possible amount of time in hours that it could take Wyatt to husk 72 dozen ears of corn?
Okay, was anybody able to figure this out on their own?
Yes.
I think so.
Yes.
Yeah, Ryan, you figured it out on your own?
Mm-hmm.
Great. Did you set up an equation, or did you just like test some values here? How did you do it?
I guess you would say test and values. I just did some mental math.
Yeah, I love it, and that's the way to do it here. Now, I've seen some kids like, the temptation. I think when I first tried to do this problem, years ago, I tried to set up an equation and like I just couldn't. It's so super complicated. But like, if you just test value, like the correct answer is going to be some number of hours, and it's probably going to be like a single digit integer, some whole, not decimal or fraction. It's probably going to be some whole number, which it is. So like, let's just test. You can test things mentally, right? So where should we start on a question like this, Ryan? What did you do?
I'm assuming he wants to get it done in the quickest amount of hours possible, and that's in 18 dozen ears per hour.
Yeah.
So at first I just doubled the 18, which
Yeah.
is 36, so
Yeah.
it's 2 hours.
Yeah.
And then I know 36 is half of 72,
I
so
love
I
it.
double it again. That's 4 hours.
I love it. 4 hours is the correct answer, right? Any possible correct answers between, I think, 4 and 6 is an acceptable answer for this question. But that's it. I mean, we're still we're plugging in values in sense, even though there's no X variable here, but it's still the same strategy, right? We're just testing actual numbers here. So, I mean, and you can start with, okay, well, 1 hour is not going to do it. 2 hours is not going to do it. 3, and then you multiply 3 times 18 doesn't do it. 4 times 18 does do it. It gives you 72, right? 5 would also work. And 6 would also work if he's husking less. But I'm not even sure how to set up the equation here on this one, but I don't care. You don't need to do it. It's basic logic. Again, dealing with actual values instead of variables. Does that make sense, guys?
Yeah.
Yeah.
Yes.
Are there any questions about this one? Does anyone have another way to solve this one?
Yes, I have a question.
Yeah, go ahead. Who is this? Who's speaking, by the way?
Christy.
Christy. Yeah, what's up, Christy? Go ahead.
You said there are several different answers.
Yes.
How is that?
Yeah, so he's got different rates of husking this corn here. He can husk it at his slowest rate at 12 ears of corn per hour, right? And his fastest rate at 18 dozen. And we're not sure what the rate is. He's got, the rate varies. So let's say he's doing 12 dozen ears of corn per hour. 12 dozen. How long is it going to take him to husk 12 dozen ears of corn? Anyone know?
6 hours.
6 hours, right? And this is just kind of mental math, right? It's going to be 6 hours because 6 times 12 is, 6 times 10 is 60, plus 12 is 72. So 6 hours if he's husking 12 dozen ears of corn. Does that make sense, Christy?
Yes, and understand how it works with the problem. I was just wondering how the test.
Oh yeah, I see what you're saying. Yeah, great question. So this is one of those where you have to write in your answer. You write in and bubble it in, and the program that scans the tests accepts as a correct answer choice anything between 4 and 6. So 4, 5, or 6 would work as an answer choice. Does that make sense?
Yes.
Okay. Yeah. So there's a number of quite a few problems where there's a potential range of acceptable answers. And I think we might see another one of those coming up today. Okay. And as long as it satisfies the requirements of the problem, that's okay. There are quite often more than one acceptable answer choices on the write-ins like this one. Okay. Any other questions? We're good.
I have a question.
Yeah. Who is this? Who's speaking? I'm sorry. Who is this? Is Christy?
No, Claire.
Claire. Hey, Claire. What's up?
Hi. I just did it,
How'd you do it?
and that's fine.
Oh, you're cutting out. I'm so sorry. Wait, can you say it again?
I just did it 72 divided by 12.
Great. Totally works. Not very different from what we did here. We're doing the opposite. We're multiplying by a potential number of hours, and you divide it by a potential rate. You get the same. You get the same thing. That's great. But again, no equation necessary is kind of that's the takeaway for a question like this one. And I think it's the danger of doing that though. What you did is that if you pick the wrong, like what if you pick 12 and divide it by 72? You're going to get a really weird number, right? If you don't pick the right numbers to do the operation with. But if you're starting with the number of hours, I think you're much less likely to mess it up. Does that make sense?
Gotcha.
Yeah. I see students that a lot, when you think in terms of operations, like, oh, I know I'm supposed to divide something by something, what do I do here? And then like, you just hope you picked the right operation. And if you think in terms of like picking the right answer choice first and testing the right answer choice, you're much more likely, to get it. Yeah. Does that make some sense?
Yes.
Yeah. Okay.
Mm-hmm.
Okay. All right. Other questions for number 31? I love it, by the way. I love that you guys are asking me some questions. I really, really, really appreciate it. That is how we learn. Okay. So number 31, I'm going to erase this. And let's rock and roll. What is next? What do we have next year? Okay. We're on practice S2 now. Okay. Love it. Question number 2. I'm going to read this one. Which of the following ordered pairs x, comma, y satisfies the system of equations above? Okay. Was anyone able to answer this on their own using the strategies we've been talking about? Anyone else?
Yes.
You guys got it? Okay. This reminds me of a problem we worked on actually in the first day, right? Where it's a system of equations, but you don't have to carry out the algebra because look at the answer choices. They give you the potential ordered pairs. So let me just plug those in for x and y. What is the correct answer here, guys?
B.
Is that right? It's B? I don't have the answer key in front of me right now, so I'm not. Is that right? It's B?
Yeah.
Some people got B. That sounds good to me. Do we have to go over this one?
No.
Or can we skip it because we've done one just like it? Does anybody need to go over it? We can go over it if we need to. I'm going to take that as a no. If anybody has questions about it, shoot me an email, and I can explain how. But again, you're just plugging in the x and y. 3 would be the x value, negative 2 would be the y value. Plug them into the equation, see which gives you a true statement. A doesn't work, it's not the right answer. Plug in the values for B, and if it works, that's the right answer. Real simple. So, all right, I'm going to just clear that one, and we'll move along. And the next one here is number 3. Oh, yes. Landscaping company. Great. All right. William, can you hear me?
Yes, I can.
You are up to bat, sir. All right. Can you read question number 3 for me, please?
All right. A landscaping company estimates the price of a job in dollars using the expression 60 plus 12 NH, where N is the number of landscapers who will be working and
You just cut out there, William. Can you go back
Hear me
to,
now?
and H is the total number. That's where we stopped hearing. Or I did, at least.
H is the total number of hours the job will take using N landscapers. Which of the following is the best interpretation of the number 12 in the expression?
Okay. I don't know if you guys are anything like me, but if I just look at that expression, like 60 plus 12 NH, I'm like, I don't know what's going on. I don't know what that means. It just doesn't mean much to me. Okay, I'm not like a math genius here or anything like that. I don't know what that means. But again, plugging in values in place of variables, we can kind of like experiment and look at this, like, and just test values and see how it changes, how this changes things. Okay, William, do you think you're able to get to work this one out for the homework? Or if you didn't get to it, it's not a problem. But I'm going to guide you through this one, William. Can you hear me?
Yes, I can.
Okay, great. Let's test some values for N and H. Okay? Let's do this. Let's make N1 and let's make H1. Okay, and just see what happens. Okay? So that means N is the number of landscapers. So that's one landscaper working 1 hour. Okay? Let's plug those in to the expression, see what we get. Looking good. Okay. And I'm just setting those values to make it real clear. N is, oh boy, my N and my H look pretty similar there. That's, yikes, there we go. Okay. Yeah, great. So we've got one worker, one landscaper working 1 hour, $72. Boy, that sounds expensive, doesn't it? That's $72 an hour. That's pretty good rate. I need to get into the landscaping business, perhaps. All right. So does that make sense so far, William?
Yeah.
Okay, good. I don't know if that gives us much insight into this problem, but you know what? I think we can already eliminate an answer choice, maybe two. We can I can eliminate two right now already. What answer choices can I eliminate? Look at the answer choices, William. Based on what we just did.
Well, I don't know if you heard me the first time.
No.
You could eliminate B and D.
Yeah, B and D. Right, why can we eliminate B?
Well, a minimum of 12 landscapers will work on the job. That obviously doesn't pertain
Yeah.
to...
Yeah, because we just plugged in one and it worked, right? Does that make sense, guys? Right? It doesn't have to be 12. That's crazy, right? We just plugged in a 1 and it's fine. I mean, it's expensive for a landscaping job, but it's fine. And then why D? You're absolutely right. Why D, William?
Well, pretty much, it says H is the total number of hours the job will take.
Yeah.
So, obviously, each landscaper works 12 hours a day. Doesn't make sense, because it could always change with the variables that we can plug into the equation.
Yeah, it's really obvious. Like, we plugged in a 1 for H, right? And it's fine. I mean, it's an acceptable possible value. So it doesn't have to be 12 hours per day. I mean, it worked with 1, so B and D are gone. Right? Come on. Right, basic logic, eliminate answer choices, okay? So this is a great example of like number 1 and 2 working in combination. Rule number 1, rule number 2, right? Plugging in values and also using basic logic. Okay, let's test some more values. Let's keep N as 1, but we'll make H, let's make N2 and make H1. Let's do that. So I think that'll make it clear what the right answer is. So N is now 2, and H is 1. Plug those in again for me, William. You're doing great. Okay. It's 84. Okay, now the price of the job has gone up by $12. But I think we can eliminate an answer choice here, William. Which one can we eliminate?
We could eliminate A.
Why A?
Well, it says... I wasn't sure about this one.
Yeah, no problem.
The company charges $12 per hour for each landscaper.
Mm-hmm. How many landscapers did we have in the second example? What was the end value in the second example? In the second one you plugged in right here. What was the end value?
We have 60 landscapers.
Ooh, not 60 landscapers. No. Remember, we plugged in an N. And here it's important to kind of keep track of what the values that you're plugging in mean. N is the number of landscapers. Does that make sense?
All right.
It tells us that, right? I mean, in the question right here, where N is the number of landscapers. Does that make sense?
Yeah.
And that's why we're testing these values here, right? That's why we're plugging in values for N and H. We're seeing how things change when we change the number of landscapers or change the number of hours, okay? So when we plugged in a 2 for N, that means 2 landscapers, and H was still 1, working 1 hour, okay? So the number of hours didn't increase, just the number of landscapers. So that means, anyone know which answer choice we can eliminate now, knowing that?
C.
We can eliminate C. Yeah, right? Because the hours didn't increase. It's still 1 hour. H was still 1. But the price of the job went up because each landscaper cost 12 per hour. Does that make sense?
Yes.
Guys, does that make sense?
Yeah.
Yes or no? What questions do you have
Yes.
about that one? This is a little bit tricky, again, because when you look at the expression like 60 plus 12 NH, like that doesn't mean a whole lot to most students. And it's easy to to get confused about what those values like the 12 and the 60 mean. But it's much clearer when you start putting in actual values in place of N and H. What questions do you guys have for number 3? No questions? Does that make sense, guys?
Yeah.
Yeah?
Yep.
Okay, I'll take it. All right. That was number 3. And then we'll clear it. And that was number 3, was that right?
Yes.
Yeah, okay, good. Okay, number 4. Yes, number 4. Ha ha ha. Ha ha. Okay, great. I'll just read this one. That whole expression there, I'm not going to read it. Which of the following is equivalent to that expression shown above? Ugh. Okay, guys, this is like exponent rules here, right? And like foiling or factoring or both, really. That's kind of what's going on. And I would say the vast majority of students like just don't have the rules for exponents down. They're really complicated. They're not necessarily intuitive. In fact, I would say some of them are very counterintuitive. But good news for you, once again, we don't have to know all the rules and we don't have to carry out all the correct operations. We can plug in some values for A and B. And once we plug those values into this expression, we'll find out what that expression equals, plug those same values into the answer choices, and see what matches up. Okay? Was anyone able to solve this question using that method?
Yes.
Who is that? Who are you?
Matthew.
Matthew, can I see you do this? Can you show us kind of what you did here? What did you plug in for A and B?
1 and 2.
Great. I want you to do it again, but here, and 1 and 2 works. Let's make it even easier. 1 and 1 works just great. Let's make A1 and let's make B1.
All right.
Does that make sense? Okay,
Yes.
so I'm going to set those values, but let me see you plug them in. A equals 1, B equals 1. Plug those into the expression up here. Let's see what we get, Matthew.
Okay.
Thank you guys so much for your participation. I appreciate it. And I know, you don't quite know each other, and we don't want to make a mistake in front of everybody. Let me remind you how many mistakes I make all the time. Oh boy. You're in good company if you are not a perfect human being. All right. Matthew, what does that equal? Yeah, buddy. 25. Okay, now I'm going to stop for just a minute. Guys, do you understand what Matthew just did here? Or no?
Yep.
He's plugging in a 1 for A, and a 1 for B. That's it. And basically, once you plug in 1 for A and B, basically you can eliminate the variables like disappear. Because 9 times 1, well, what's 1 to the power of 4, guys?
1.
1, right? 1 to the power of anything is 1. 1 to the power of 100 zillion is 1. And so basically, it's 9 times 1 plus 12 plus times 1 plus 4 times 1. So the variables just melt away, right? And you're just dealing with good old numbers, right? You guys could solve this problem here in like, 3rd grade. So really simplifies this. All right. So when A is 1 and B is 1, the expression is 25. Now the question is, the correct answer choice should give us a 25 when we plug in a 1 for A and a 1 for B. Matthew, let me see you plug in a 1 for A and B in answer choice A.
Okay.
$25, right? Because 3 plus 2 is 5, and 5 squared, which means 5 times 5 is 25. So that looks pretty good. Now, hold on. I got to stop you real quick. When we're plugging in values in place of the variables here, guys, please understand this, all right? It's possible, in fact, it's very common that you'll see more than one answer choice that gives you a true statement. So really, we need to test all the answer choices here, okay? Don't just stop when you see a true statement, okay? So let's plug these into B as well. But we can't eliminate A. A's looking good. Can you do the same thing, Matthew? Plug, yep, there you go. Good. Oh, stop. A little copying there. Yep, what is that? It's the power of 4. Okay, now stop real quick. Do we need to calculate this, Matthew?
No.
No, we do not. Why? Why do we not need to?
Well, because it's huge.
It's huge. Yeah, it's not 25, right? And the correct answer has to give us 25. That's it. That's that simple, right? Does that make sense, Matthew?
Yes.
Great. I love it. All right, let's plug them into answer choice C. 1 for A, 1 for B.
Okay.
Looking great, Matthew. Looking great. How's that?
That's still pretty big.
That's still huge, right? Because that's 13 squared, which is 13 times 13. It's not going to be 25. Does that make sense?
Yes.
Right. Again, I mean, if you can avoid having to like carry out a big calculation like that, don't worry about it. You can just use your logic and eliminate it. What about D? Do we even need to plug in numbers for D?
It's way bigger.
It's way bigger. Yeah, like if C's too big, D's way bigger. We don't have to worry about it. So we can confirm it is answer choice A. Does that make sense, guys? And gals? Yes? Go ahead.
Why did we have to go through all the other answer choices if we found the correct answer?
Aha, right. Well, and it varies from question to question. Great question. I love it. What if they give you an answer choice? I know there's no answer choice E, but let's say there was an answer choice E that said, that gave us, it was like, 5 times 3A plus 2B. Right? What if that was an answer choice? And you plug in your A and B values, right?
Yeah.
And you get 25. Now, that's not an equivalent expression. It's not. It's just not the same thing. But it's equivalent if you plug in a 1 for an A and a 1 for B. It just happens to work out that way. And sometimes they design answer choices anticipating this strategy is so powerful, they have to anticipate you're going to do it. Right? And it's so effective, it's almost like cheating. So sometimes they throw in answer choices like that. If you plug in obvious like zeros and ones, then you'll get 2 answer choices that give you a true statement. Does that make sense?
Yeah.
Yeah. So you gotta be careful. Which is why, and it's not a problem because like generally, let's say they gave there was like an answer choice like answer choice E. Okay, we've got 2 correct answer choices. Now let's plug in a 1 for A and a 2 for B, and see if we get a true or honestly even you could do like a 1 for A and a 0 for B, and then that would tell you that oh no, only A works and E doesn't work.
Yeah.
Does that make sense?
That makes sense.
Great question. Thank you so much for asking. I really, really appreciate it. Any other questions about this one?
Why don't you just plug in 2 different numbers for the variables in the beginning?
You could. I mean, you could do like, look, if you wanted to do like 2 and 3, 2 for A and a 3 for B, you could do it. But how long would that take? It would take a while, right? I say start with like the easier values, and then if you need to make them bigger, you can do it later. Here, you don't need to. If you plug in a 1 for A and 1 for B, it works great. You could plug in a 1 for A and a 0 for B, and you could eliminate the incorrect answer choice. Then you're doing even fewer calculations. Because only one A, right? Think about it for a minute. If you plug in a 1 for A and a 0 for B, what does the expression here equal? If A is 1 and B is 0.
Just a sec.
Well, 0 times anything is 0, right? So anything with a B is going to be 0. Right?
Yes.
So the expression is just going to be 9. If A is 1 and B is 0. Does that make sense, guys?
Yes.
Yeah. Yeah? Any questions about that, or does that make sense? Okay, so then if we plug in A, to go back to the answer, is plug in a 1 for A and a 0 for B, that becomes 0, and we just get 3 squared for A, which is 9, and that works. And none of the other answer choices would give us a 9. Then I'll be way bigger than 9. Does that make sense?
Yeah.
Yes.
Yes? Questions about that? That was number 4, is that right? I think. So let's do number 5. This looks a little bit familiar, because I think we did one of the homework problems looked a lot like this, but it's a different question. So give me Hudson. Oh, no, we are at Blaze. Blaze, can you hear me, Blaze?
Yes.
Great. Go and read question number 5 for me, please.
If k is greater than 0 and x equals 7 in the equation above, what is the value of k in 2k squared?
Yeah, that
plus
whole deal.
17?
Yeah, don't worry about that. All right, so what are we going to do here, buddy?
Plug in values for k.
Great. And also x, right? Because x is 7.
Well, yeah, plug in
Right.
7 for x.
Yeah, absolutely. Okay, let me see you do this. Can you work this out?
So let's just try a first.
Mm-hmm.
2 squared. Then I'm going to have to make this longer.
Yeah, absolutely. You want to be careful there. Make sure that,
Plus
because that plus 17 is inside the square root sign here.
17 minus 7 equals 0. Oh, whoops. Sorry, that looks like a 6.
No, you're good. You're good. I got you.
0.
All right. Very
Okay.
good. Okay.
So
What do we do
2
now?
squared is 4.
Absolutely. Looking good.
Then times 2 is 8. Plus 17. 8 plus 17 is 25. Minus 7 does not equal 0.
Yeah, and remember that 25 is in the square root sign,
Oh, yes, that's right.
right?
So, yeah, the square
So don't
root of
forget that.
25,
Mm-hmm. And what's the square root of 25?
5.
5, right?
Minus 7, it's
No,
not 0.
It's
so
not
we
equal
can-
0. So we don't have to worry about answer choice A. That's gone. Now let's think about this sort of logically. Okay, at this point. What is this thing in the square root sign gonna have to be to get a 0 on the right side of the equation?
Do you mean k?
Well, no. What's the thing inside the value inside the square root sign? What's it gonna have to be?
It's going to have to be 49.
It's gonna have to be 49. Does that make sense, guys? Why we know it's gonna have to be a 49 inside the square root sign?
Yeah.
Because what's the square root of 49?
7.
7. Right? So it's going to have to be that when we calculate what's inside the square root sign, it's going to have to give us a 49. Okay? So, we can let's just go through the rest of the answer choices.
So, next we'll try B. So, the square root of 2 times 3 squared is 9, so 18.
Mm-hmm.
Plus 17.
Do you see what he's doing there, guys? He's just kind of calculated 2 times k squared, which is 18, when k is 3. All right? And what does that give us?
That gives us, again, 25.
Double check there.
Oh, sorry, 35.
35. But regardless,
Minus.
not 49.
Yeah, so
Right?
we can already cross that
Yeah,
one off.
don't even worry about it. Yeah. B is gone.
So then,
Let's try 4 for k. Any questions, guys, about what he's doing here? We're good? Okay.
2 times 4 squared. 4 squared is 16. 16 times 2 is 32.
Yeah.
Oh,
Just
okay,
doing some arithmetic here.
32 plus 17. I think that equals 49.
That's looking good.
Then minus 7 equals 0.
Done.
So 32 plus 17 equals 49, which the square root of is 7.
It's 7. You got it.
Minus 7 equals 0.
That's it. It is C.
So I think C is the answer.
That is it. Questions about that, guys? Yes or no? Questions?
I got that one.
No? We're good? Okay. Awesome. Great job, Blaze. Great job. All right. Let's do a couple more. We'll take a break here in just a couple minutes. In case you've been drinking as much coffee as I've been drinking. And you need to take a break. That was number 5, is that right? I think that was.
Yes.
Okay, good. Number 8. Ooh, this one's interesting. Okay. And let's hear it from Hudson. Hudson. Can you hear me, Hudson?
Yes.
Great. Go ahead and read question number 8 for me, loud and proud, please.
The measure A in degrees of an exterior angle of a regular polygon is related to the number of sides n of the polygon by the formula above. If the of an exterior angle of a regular polygon is greater than 50, what is the greatest number of sides it can have?
Okay, let's talk about this question just a little bit. I think one of the trickier parts of this problem is just kind of figure out what it's asking us. Okay? What is it asking us to solve for here, Hudson?
The exterior angle, well, how many sides it can have?
How many sides this polygon has, or at least the greatest number of sides this polygon can have, whatever it is, right? Polygon's just a shape, right, with a certain number of sides, right? Okay.
Yeah.
So the answer choice here, A, B, C, and D, these are all potential values for which variable?
N.
N, right? Okay. So if we plug these values for n into the equation above,
Mm-hmm.
the correct answer choice has to give us some value for A that's bigger than 50 degrees, right?
Mm-hmm.
Does that make sense? Yes or no?
Yes.
Right? Because it says if the measure of the exterior angle of a polygon is greater than 50 degrees, what's the greatest number of sides it can have? So let's see the greatest value for n that gives us an exterior angle, an A value, greater than 50. Does that make sense, Hudson?
Yes.
How are we going to test this?
So we do 5.
Yeah.
Times A
Okay, great.
equals equals 360.
Yeah.
Divide that by 5.
Great.
And A.
You can use a calculator here if you like. I'm not sure this is the I think it's not in the no calculator section, but I guess the question is that bigger than 50?
It is greater than 50. It's 72.
Yeah. That is. Okay, good. Any questions about that? Does it make sense what you do here, guys?
Would there be any way to solve for A without using algebra, or
Well, I don't know. Well, hold on just a second. I don't know if it's A yet. We don't know that.
no?
All right. Now, A gives us a value bigger than 50. Okay. But what if 6 works and gives us a value bigger than 50? Right. 6 would be a better answer choice. Or if 7 works and gives us a value bigger than 50. Does that make sense, Hudson?
Yeah.
And this is why it's so important when we're using this strategy. Don't just go with the first answer choice that gives you a true statement. You really don't want to do that. You want to cycle through all the answer choices because you want to be able to confirm what you think is the right answer choice and also eliminate all the incorrect answer choices. You're guaranteed to get it right if you do it that way. Go through all of them. Does that make sense?
Yeah.
Okay. So So what was the other question? Is there someone asked me a question?
Oh, if you could solve this without using algebra.
Yeah, I mean, boy, I mean to solve without solving for A. I mean, it would be tricky. I think the easiest way here is just divide both sides by 5 to find out what A is. I think that's you could test values for A potentially until you get something that gives you a true statement. But the easiest thing here, I think you can all pretty much solve for A here at that point. Can we agree with that or no?
Yeah.
For the most part, like if you've done it, like again, this is like it's not even algebra 1. That's like 8th grade, like pre-algebra. You know, that's pretty basic. Divide both sides by 5. Okay, let's plug in answer choice B.
Okay. 6. Equals 316. Divided by 6. 8.
All right, is that angle bigger than 50?
Yes.
It is, right? And so you see now why we can't just go with the first answer choice that gives us a true statement. We can, however, eliminate A because it's not the biggest side that gives us an angle bigger than 50. Does that make sense?
Yeah.
Let's plug in C. Bigger than 50. All right, bigger than 50. So C is a possible answer choice here, right?
Mm-hmm.
Okay, but we can eliminate B because B is not the biggest. Lastly, let's try 8. And let's just do this real fast, right? We see the operation now, right? We just divide 360 by the number of sides. So let's divide 360 by 8, see what we get.
Yeah, so it's less than 50.
Okay, it's less than 50, so we know D is gone. Questions about that question?
No.
Questions in general?
Nope.
Complaints?
Would it be okay if you just did 360 divided by 50 in whatever choice is closest to that?
Yeah, but the problem with that is that, like, okay, so go ahead and do that.
Yeah, you get 7.2.
Yeah, so what do? You know, what do you do with that exactly, right? You might be like, I mean, you could, but I think it's more clear by testing the answer choices, at least just as a general strategy.
Okay.
Right, being able to confirm the right answer choice with absolute certainty. Because there are some where, like, if you kind of do an operation like that, I mean, you might get a value close to another incorrect answer choice. It happens all the time. So you'd probably get it right here if you did that. You would. But as a general sort of overarching strategy, this is still the best approach. Make sense?
Yeah.
All right. Let's do one more, and then we'll take a little 3-minute break here. All right. That was number 8, so let's do number 10. All right, and we are at Jonathan. Jonathan, read number 10 for me, please.
Okay. Which of the following equations has a graph in the xy plane for which y is greater than or equal to -1?
Ah, okay. Okay, graphing here, okay. Now look, I don't know how to graph all these. I don't. I'm assuming you guys don't either. Can we agree on that you don't know how to graph all these?
Yeah.
Right. So there's got to be another way to approach this. And of course, we're going to be testing values, of course. But there's got to be another way to approach this where we can find out which graph has a y value that's always greater than or equal to -1. Okay.
Do we plug in -1 in as y?
Yeah, we could start. Well, we could do that, but I think there's a better approach here, which is that let's test values for x, and we're just going to come up with some of our own values, and see if we can make the y values here somehow less than -1. And if we can make a y value less than -1, then we know it's not a correct answer choice.
Okay.
Does that make sense? Yes or no?
I think so.
Okay. Read the question for me again. I think it'll make more sense here.
Which of the following equations has a graph in the xy plane for which y is greater than or equal to -1?
So for the correct answer, y is always going to be, no matter what we plug in for x, y is always going to be greater than or equal to -1 for the correct answer choice.
Okay, yeah.
Right?
Yeah.
So if we can somehow make, for a particular answer choice, we can make the y value less than -1, we can eliminate it. Does that make sense now?
Yes.
Okay, good. All right, so let's do that. Let's see if we can let's test answer choice A. Let's see if we can come up with a value for x that will give us a y value less than -1. Can you do that for A? Give me a value for x. Let's just plug those values.
Just use 1 then.
Yeah, plug in a 1. Okay.
So 1 minus 2, and that's just 1 minus 2 equals -1.
Okay. We haven't made it less than -1. Can you think of a value for x that would make y less than -1?
Well, not really because of the absolute value. So
Can anybody else? I can think of a value that would give us a y value less than -1.
Yeah, I guess 0.
What value? You see it? There
0.
you go, buddy. 0. Now let's talk about absolute value real quick. Do you guys know how absolute value works or no?
Yeah.
Yeah? Does anyone not know how absolute value works? I think we covered it in the last session, right? It's on the rules for mathing. There's a section on the basic concept cheat sheet that addresses absolute value. Check it out if you're uncertain about it. But does it make sense why when we plug in a value for 0, we get for x, we get something less than -1 for y? Does that make sense?
Yes.
Okay, and does that make sense? We can eliminate A then, because we get a y value of -2, and that's less than -1.
Mm-hmm.
Okay. Questions about that? All right, let's try B.
Well, I guess we could try 0 again.
Try 0 again?
0 squared, which equals 1.
I wouldn't be so sure about that.
Wait, no.
What's 0 times 0? What's anything times 0?
0.
0, right? Now, anything to the power of 0 is
thinking
1, and that's what we covered that actually in the previous session, right?
Yeah. So that equals -2, so that one can't work.
That's a -2, so it can't be B.
Yeah.
Does that make sense, guys? Why we can eliminate B? Yes or no? Does that make sense?
Yes.
Yes.
Okay, good. Let's try C.
Okay. I guess 0's been working. Let's just keep with 0. So
Yeah.
0 minus 2 squared. So that's -2 squared.
Now hold on just a second. It's a -2 in parentheses
Yes.
squared. I just want to make that real clear. Because that means -2 times -2, which is 4, right?
Yes.
That would be different from -2 squared. That would actually be
'cause the
-4,
would be
right?
outside.
Because that means, exactly, because that means 2 squared,
Negative.
and then you're making it negative, right? Does that make
Yeah.
sense?
Yeah.
Okay. All right. So, okay, so that's positive. Can we let's test another value for x to try to make that negative, or something less than -1.
Do -1.
-1, great. Yeah,
Okay.
great. And I think we're starting to see a problem here, a good problem.
Yes. So that's -3 squared equals.
It's a 9, absolutely. Is there going to be any way for y to be negative?
No, not on this one.
Not for C, right? And this is this is the concept they're testing you on here. And I think I've got actually on the rules for mathing here. Let me check it out real quick. It's one of the basic concepts. I think one of my there we go. And it's on exponents, right? Which is that x squared will always be positive. There's no way for it to be negative, right? Because if x is positive, then of course a positive times a positive is positive. But even if x is negative, a negative times a negative is also going to be positive. So there's no way that y is going to be negative, let alone less than -1. Does that make sense?
Yeah.
C is looking really good, okay? But let's try to confirm it and let's try to eliminate D real quick. Can you think of a value for x that will give us a value for y less than -1?
-1.
Yeah, -1, right?
Because -1 to that equals -1.
Exactly, right? -1 to the power of 3. If it's odd, right? An odd, a negative value to the power of an odd number is going to be negative.
Yeah.
So that gives negative. Or 0, once again, too. Plug in a 0 for x and we get -2 for y. So we can also eliminate D. Any questions about that, or does that make sense?
That makes sense.
Okay. No graphing necessary there. I wouldn't recommend it. I mean, trying to graph those would be very complicated, really complicated. And this is the no calculator section. So, but plug in values, you can do it. Okay, let's take a 3-minute break. Run to the restroom, get some coffee. Both. I will probably do both. I might eat some bacon in there as well, and then we will pick it up where we left off. All right.
All right.
See you guys in just a couple minutes.
All right.